Ladies and gentlemen, please welcome our next speaker, Thomas Schuetz, presenting the topic, Unlocking the Tech Wonderland, Combining GitOps, Platforms, and AI.
Hello everyone. How are you today? Perfect. Okay, so hello everyone to my talk about GitOps, Platforms, and AI. To the third word in this topic, the main part of AI was the title here, right? So I think every one of us, when we create some talks and so on, we let the AI generate our titles, and so was this one. I will get more creative in the future, hopefully. So some words about me. So my name is Thomas Schuetz. I can pronounce myself. I'm a principal cloud architect at Keptn, so this is a tolling company in Austria. And I'm a CNCF ambassador, so I'm traveling around the world, around Europe and so on, talking about cloud native technologies, platforms, and so on. I'm an open source enthusiast, so I like working on open source projects, I like using open source projects, and I like also to talk about open source projects. And last but not least, I think that there should be more technicians and cloud people out there. Therefore, I'm also teaching cloud native technologies and Kubernetes and so on at universities in Austria. So what is this talk about today? So I dealt a bit with some questions in the last few months, weeks, and so on. And I often hear from students and people out there in the industry, Kubernetes is so complex. And I just wanted to discuss this a bit and talk about it. The second thing I always hear from many people is that the cloud native ecosystem is so large and there are so many things out there. What should I use? The third thing, and this is the main part of the story, is the emergence of platform engineering and how this relates to the other two questions. Then I want to get a bit more into streamlining and simplifying deployment using GitOps. And in the end, I want to give you some ideas how we could find out if everything we are deploying is working. So as you might have noticed, the agenda is pretty large. Therefore, I will start. So to my first question. So everyone tells me Kubernetes is complex, right? Whom of you thinks Kubernetes is complex? Okay. And how many of you think that it's not complex? Okay. And how many of you are 10 to 15 years Linux and Unix admins there? Okay. So perfect. So to the first point. So just for those who aren't aware of Kubernetes, and I think these are the fewest ones. Kubernetes is a container orchestration platform that builds declarative abstractions for things happening on the system. So, for instance, if we tell Kubernetes create a pod, then it's nothing more than telling a Linux system that it should create a namespace, that it should run a process, and it should encapsulate something in the namespace. Nothing more, nothing less. The only thing we have behind it are some controllers and so on, which are dealing with the task. But in fact, it's open source and everything is transparent, right? The second thing, and this is what this is about, sometimes things get a bit scary. So we have lots of things to configure, we have lots of abstractions in there. And with all of these abstractions, it might get pretty hard to find out what's happening in detail at the moment. But also, in fact, we can take a look. And let's say in the most cases, and then I barely got few things where it wasn't reproducible. It works perfectly fine. And for those of us who are in the Linux and Unix space for a very, very long time, and this was what I asked before, if you think of ancient times, everything is pretty simple. So let's think about, we wanted to have some high available, scalable systems and so on. We had or have some such things as cluster managers. We have such things as heartbeat mechanisms, and we have to deal with failover. And these are only some examples of this. And this also scared me in the past. So I think it took me hours, months, years to understand what's happening in my system sometimes when I was younger. And when it comes to these things, also the configuration of all of this was very scary. So when you're thinking about creating a cluster system which is running on a high number of nodes, which should automatically scale, which should automatically fail over, and so on. At first, it would take you some time to configure it, and secondly, it will take you lots of time and braveness to maintain this. So when we are thinking about a typical Kubernetes thing, and I know I'm getting into depth there a bit, but I just wanted to show you a simple example. So in this case, I created a simple ingress manifest here. And I know it's pretty small here, but what you see here is that we have two annotations in there where we say this ingress object, so a thing which gets into my Kubernetes cluster, should get a certificate which is issued by some issuer, and the DNS entry should be configured. And when we got all of this in Kubernetes, or some controllers which we have in our cluster might say, yes, I am the ingress controller and I am responsible for making this service available in my cluster. Easy as that. The second thing we might get is a tool called Cert Manager or whatever, if installed, says, yes, I'm see the annotation in this object. I know that I'm responsible for certificates, and I will take care about that this certificate you want here gets available to your application. And last but not least, I might have a third controller in my Kubernetes cluster, which says, yes, and you need an external DNS entry. So I will go to the cloud provider, will configure the DNS entry, and everything will be fine in the future. Will be fine afterwards. I know this is described very simplistic at the moment. So when we take a look at this picture, it might look like, yes, Kubernetes can do everything. And this comes with some effort, to be honest. So when configuring this, it might take about 5 to 10 minutes to get this working. Think about how this was in the traditional infrastructure space. Good. But when we are dealing with Kubernetes and so on, and this was the same for me when I started with this. In the beginning, the learning curve is very steep. So the first thing, the first problem I had when I started dealing with Kubernetes was I wanted to spin up a container, and the second thing was I wanted to start to connect there via SSH. Today I wouldn't do this. The next problems I had were such things as storage and getting things outside of the cluster. So this is what I meant with the learning curve is very steep. But the other and very cool thing is it's still working on mostly on Linux machines, right? So all of the mechanisms we know below it are still Linux mechanisms. So when we want to create a service or when we want to create similar objects, we always have Linux mechanisms below it, which get configured by the controllers and not by us. So when we want to create a service, it's nothing more than with some networking plugins, than creating IP tables rules, which make this service available to the outside and inside of the Kubernetes cluster. And the third thing is you need a really good overview about the ecosystem to get things working. So as you've seen in the picture before, you might get many products involved, you might get many projects involved, and you should be able to find out which things fit better to you. But this is where I come to in a few minutes. So let's go one step further to the cloud native ecosystem. Whom of you knows the cloud native landscape? Whom of you thinks it's too large? Okay. Good. So this is only a part of the cloud native ecosystem. So the top part at the moment. And yes, I agree. Sometimes it can get a bit hard to get through it and find out what you want to use there. And also, when I was at the university and talked about cloud native application delivery and so on, many of the students asked me, so good, there are projects out there like Flux, there is a project called ArgoCD, there is a project called Keptn and so on. Many of them are doing similar or the same things. And why is it this way? And what should I do in this case? So to the first question, why is it this way? It's open source. Everyone is free to do whatever he or she wants. And therefore, many projects are out there, right? The second thing is, the different projects also have different opinions and approaches. So, for instance, you might want to have a tool out there which has a fancy UI, which is pretty easy to use by the people and has a strong opinion. Perfectly fine. So if you want such tools, it's perfectly okay to use them. On the other hand, there could be more technical things out there where you need to know in-depth knowledge about what's happening on the inside. You might want to implement your own opinion in there. And therefore, there are other projects out there. So the different projects in the open source space are created because of such things. Because one project means, yes, I have this opinion, and then the next project and the next problems will come up, where the people say, I cannot put my opinion in the same project, maybe. So I will create my own one, and there from this such open source projects evolve. Finally, I read the book Cloud Strategy from Gregor Hope, where he talked about finding the perfect cloud provider for your company. And I think that's the same for open source projects and for the cloud native ecosystem. So you should always try to find these projects which fit the best to your approach and to your company or your system. So as I told you before, you can use tools which are in there which let you configure almost everything. Perfect. But sometimes you don't want to configure everything. Therefore, take the easier part. So when we come to operating such systems and creating applications for those systems, I, as a pretty old systems engineer, have always a pretty simple assumption. So if I were a developer, and nowadays in times of DevOps and so on, I am a developer, I don't directly care about the ecosystem. So I think there should be people in the company which should be aware of this, which should be able to help me. The only thing I, as an application developer, want to do is I want to get my application running, and don't want to care about installing and configuring its dependencies as far as possible. So for instance, if my application uses a MongoDB and so on, it should be pretty fine, but there should be something where I could say, yes, for my application I need a MongoDB, and where is my connection string? Same for any relational database and so on. So to get there, I want to talk a bit about the emergence of platform engineering at the moment. And to start with this, I would like to start with the simple definitions of a platform, which we have in the CNCF Platforms white paper. I think this was taken from Martin Fowler, where they say, a digital platform is a foundation of self-service APIs, tools, services, and knowledge and support, which are arranged as a compelling internal product. And for me, this sentence is very powerful. So, because for me, when I'm using when I'm creating or using a platform, the first thing I'm always taking care of is that end users could use this by themselves without me having to configure everything. The only thing which should be possible, which should be needed from me as a platform guy or whatever, should be the approval of a pull request if they want to use services from it. The same with tools. So tools should be provided to use the platform itself. Services can be things as the database, as the interface to the database, and so on. And such things as knowledge and support. So how to use the things we have in the platform at the moment. And one of the things which is more and more emerging is that all of this gets arranged as an internal product. So when we are talking about what was happening in the pre-DevOps time, we always thought about infrastructure as a project. So we said we want to update to Windows Server 2012. Or we want to change, we want to update from Postgres 5 to 6 or whatever version is out there. But in the meanwhile, we should have some templates, we should have some mechanisms and so on out there where this is not a project anymore. This is commodity. This should be done automatically, and the only thing, and someone has to provide this. And with all of this, autonomous delivery teams can make use of the platform and deliver product features in a very high pace with reduced coordination. So as everything is self-service, as everything is maintained as a product, it can be used in a very simple way. So this is also a picture I've taken from the CNCF platform white paper. And this is more the conceptual part of the story. So to not go into deep with this, we in the bottom of all of this, we have some we might have capability of service providers. So for instance, this could be our cloud providers, hyperscalers as Amazon, Google, Azure, Exascaler, however you want to call them. And on top of them, we can build platform capabilities. So for instance, for me, the whole deployment part of the story is a platform capability. Some secrets management is a platform capability. All of the database services, messaging, and so on we are needing in our platform are platform capabilities. And on top of all of this, we could have some interfaces where people or systems can interact with our platform. So for instance, we could have some APIs where a developer could say, yes, I want to get a database from this and this. But this could also be Kubernetes custom resources where developers say, yes, and I need this object. I want to create a pull request and simply do this. And on top of this, and this is the end, we have our product and application teams, which can use all of the things we have in the platform in an abstracted way to create their applications. Welcome in Wonderland. Good. So what does this mean if we go to a more in-depth technical level? So at the moment we were at a scope where we said, yes, pretty fine, I have services, I have templates and so on, but how could I get there from a technical standpoint? And this is only one illustration about things where I could say, yes, this could be kind of a technical platform for me. But this might also be different in other cases. So things I need to get into the platform from a developer perspective. I need to get a developer portal, and I'm pretty sure that at this conference there is some talk about backstage or whatever, where you can create, where you can have an entry point into your platform, where you can have some documentation, where you can have some self-service things inside and so on. The other thing we could have are some platform APIs, such as RESTful APIs, or as I said before, Kubernetes custom resource definitions. And with this, we could have many things inside of our platform. So for instance, if a developer wants to create a new service, then he or she should not need to start from scratch, right? So it might be cool to have some kind of a platform template where a service template, sorry, where the developer can say, yes, I want to create a new Golang service, and I want to get my pipelines configured, I want to get the documentation configured, and so on, and everything runs automatically. The second thing we might want to have, if we deploy this to a larger scale, we might also want to have an environment template. So we might want to say, I have not one production cluster, but 200, and this should look like the same, should look the same in any case. And with this, we can create some kind of infrastructure. So I, for myself, I prefer to have everything which is configuration and so on in a Git repository. Therefore, for me, if it's not in Git, it's only a rumor. And I want to have controllers which are taking care about deploying the infrastructure themselves, which are taking care about deploying the environment, and which are about configuring everything. And with this, I get services and ingress objects and service interfaces, or the services themselves, in the Kubernetes clusters. I get some things as load balancers configured automatically outside of the Kubernetes clusters. And maybe if I say I only want to use PaaS services, I could also automatically configure all of my PaaS services out there. And last but not least, and this was a thing I saw in the last talk, is observability should be a core part of all of this. So when we are creating such things, we should be able to find out if everything works as intended, how it works, and we should also be able to find problems if something breaks. So, okay, and now the picture couldn't get loaded. Then I will simply skip it. Last but so one thing I wanted to show here, unfortunately it doesn't work. So on the picture there was more or less a tool store where you could say, yes, I have some sellers which might be the contact points where I could get some proposals on how to build a doghouse. So this would be more or less my platform interface, my knowledge thing, and so on. I could have the shelves by themselves where the wood parts and so on are in there, and could say, yes, this is my self-service API in the end. And in the end, it's myself who fits all of these parts together and tries to build the doghouse based on my own wishes. So when we are building platforms, at the first step, it might everything sound like a pretty technical topic. But in fact, it isn't. So because everyone could say, yes, I want to build a platform, here are my 5 tools, create a repository, create an ArgoCD application set, and just do it. But if you want to raise this to a higher level and operate this in a large scale, in fact, it's all about the people. So when you are going to your platform journey, and if you want to get such things successfully working, it will not work without people. So the first thing I always approach is I try to include and involve the people in my platform initiative as far as possible. So when building such things, I try to approach the people and say, yes, what do you expect? Or if you need some additional service or whatever, maybe work on this together. Because in fact, when we are working in one company, everything is paid by the same by the same people or by the same other organizations, and therefore everyone should put on the same strings, right? The second thing, which might be very important for such approaches, is to inner and open source your platform services, because you can build platform things silently in a room, but nobody will take care about it and nobody will know about it. And if you make this publicly available and say, yes, and this is our platform, there is nothing secret in there, and you can use whatever you want there. And if something needs to be changed, or if you want to improve something, just raise a pull request. Then I think the acceptance of such things will get much better than if you do it in a central site. And last but not least, such efforts cannot work without community approaches. So build a community also inside of your company. Talk about successes, talk about things which are not working as good as possible, and try to give the people a voice and help them telling their stories. And one thing what I want to go technically a bit more into depth here is, when we are building platforms, at the first step, and this was also my approach at the beginning, I can build platforms pretty cool. I can go there with a blank sheet of paper, can draw one square, can draw a second square, and so on. But sometimes the point will come where I deploy a first system, and this can get pretty hard at some point in time. So what I learned in the last few years was that deployment influences platforms more than you might think. So we have several action fields in there. For instance, the first things I stumbled across when I built the first platform like thing was, I have Kubernetes Helm charts, I have a pipeline, and how do I deal with secrets and configuration in an automated way now, if everything is in GitOps? There are many solutions out there. So there are external secrets, there are sealed secrets, you have KMS in various cloud providers. You should be only aware of them and should build them inside of the platform as early as possible, let's call it this way. Then we have a very cumbersome topic, and this is a versioning topic. So in theory, every service we have in our platform should be deployable independently, right? Whom of you thinks this is this way? Okay, whom of you experienced the counterpart? So that it wasn't this way? Okay, the same one. So, and this was also what I thought of when I started with my cloud native journey and so on. So everyone told me, yes, your microservices and so on should be deployable very independently from each other. And if you want to deploy a new version, just do it. And what I found out was, in many cases, this won't work. So especially if the company is worked in monolithic times and so on. So versioning in such things is a very strange topic because you might have various versions which should fit together. So you have service versions, you have application versions. In the end, I had infrastructure versions, I have infrastructure module versions, and so on. And also, if you think about your GitOps things and so on, also the things you have in GitOps should not always be so it might not always be the wish of everyone to deploy on a system when something is merged to main. So you might also have releasing thing, versioning thing in there. Therefore, when working in GitHub environments and so on, tools as Renovate, and I think the second one was Release Please, got my best friend. To be honest, for GitLab, I don't have a good counterpart at the moment. I started creating an open source project for that, but I'm also not sure about this. So these are always things which are hard to deal with, so all of the releasing parts of the story. Another thing I dealt with in the last few years, and this gets better and better, are the things about infrastructure and application dependencies. So when you want to deploy an application, you might need some kind of a database behind it. But this database has to be provisioned somewhere, and you need load balancers and whatever. And there might be different tooling for this. So you might have Terraform or OpenTofu on the one side, and you might have a GitOps controller on the other side. So how do you orchestrate them? Therefore, I will show you some kind of an approach afterwards, but you can also manage many of the application dependencies in Kubernetes clusters with crossplane. Would also be a valid approach, but you should be aware of it. And the last two things we have there are, do we want to follow Kubernetes infrastructure deployment, so as I said before, with crossplane or whatever, or do we go typical infrastructure as code approach as we learned it in the last few years with Terraform OpenTofu? And last but not least, what also has an influence on your platform strategy is, am I using PaaS services? So do I only need interfaces to the provider, or am I maintaining the services on my own? And this is always a question which you can answer yourself by the capabilities of your team. So, for instance, if you have hundreds of database specialists who can maintain stretched clusters across five data centers to fulfill the customer's needs, then maintain them by yourselves, because at some point it might be cheaper. But if you don't have the manpower in-house, I think this question, the answer is pretty easy to say, yes, let's use the things provided by a cloud provider. So, sorry, I have problems with the pictures today. But it worked before. So what I wanted to show here is, and just imagine it a bit. So I've showed a very big picture there, where I showed how such things could be deployed. So at first I had Terraform or whatever, which had a pretty cool line to the cloud provider API, where we say, yes, and I want to spin up a Kubernetes cluster. And the second line I had was, I'm also using Terraform or OpenTofu or whatever to install the GitOps controller on this cluster, and to install my secrets management solution on this cluster. Because at some point in time, I might need secrets, and I will need secrets earlier than you think, because when I firstly access a protected repository, I need my first secret. Therefore, I need to have it in the beginning. But what I'm doing typically is that with this, this is the only things I'm deploying via infrastructure as code, or mostly the only things, if I'm using everything in my Kubernetes cluster. So the rest, what I will install afterwards, is always coming from the GitOps repository and so on. This and this in a way where people could say, I only have to create a new path, I have to create a config file and a values file for the Helm chart, and in the end it will work as intended. And sorry again for the pictures. So and everything we are doing here, we might want to ensure that the quality of our deployment fits the things we expect from it. So when we reliably want to deliver software, we might trigger our deployment somehow. So we might have some kind of a pipeline which says, yes, deliver it. Or we might have an image updater from Argo or Flux or whatever, which says, yes, a new version of the image is there. Please update manifests and then start the deployment process. And in the end, we will start deploying our services. So this can be done by Argo, Flux, or however you call these things. For the deployment process, I always try to follow an approach where I say, yes, I want to deploy something. I want to find out if this works. If it works, everything is fine and I can shift the traffic. And if it doesn't work, then I will try it again. So I'm typically following canary and blue-green approaches to decouple the deployment part of the story from the releasing and traffic shifting part of the story, to get the risk a bit out of it. Because in fact, the most riskful operation we have in this part is the deployment itself. And if the deployment itself went well, then the second riskiest thing in there is the application part. So, and with this, I have 2 or 3 steps where I could say, yes, I deployed it, everything's fine, perfect. If not, nothing happened, hopefully. In the second case, I could say, yes, I want to find out if my application works, so do some synthetic tests, do some end-to-end tests or whatever. And in the third step, shift my traffic and say, yes, this service is now responsible for this deployment. And for this, we have many tools out there. So as I said before, for deployment and for deployment itself, we have ArgoCD, Flux, Octopus Deploy, and whatever. For the whole quality part of the story and shifting traffic, we have Argo rollouts, we have Flagger, and also Keptn can help us to get this in there. And also for validation, and this is, you can always put in external services which might help you. So for instance, when sometimes I used Keptn to trigger other things that validates if everything works in my Kubernetes cluster. And one of these tools was an open source project I'm also working on, or worked on a long time. And this is K8sGPT. And some of you might wonder, what is K8sGPT and why do we need it? And yes, this is the second AI part of this talk. So why did we create K8sGPT? So as you might have noticed and heard before, Kubernetes is pretty complex, and troubleshooting Kubernetes can be really cumbersome. So I, for myself, I created lots of Kubernetes deployments in my last few years, and I had the problems with missing service accounts not once but not twice, and I think about 10 to 12 times. So in fact, we as SREs, we as DevOps people and so on, we are able to detect the problems, but we are not always on the right path from the beginning. And we are often definitely not the first one hitting this problem. So the whole service account things I showed you before. So at least I by myself, I had the problem, I think, about 12 times. And every time I asked other people, many other people also raised their hands if I asked them if they had the problem. And yes, we are always troubleshooting the same issues, right? And this is time consuming, this is cumbersome, and in the end, sometimes frustrating. So what we wanted to achieve with K8sGPT is, why don't we automate the detection process and also let AI help us solve the problems? So one of the most common misunderstandings of K8sGPT is that it takes Kubernetes manifests, puts everything in a prompt, and send it to the AI provider. But in fact, what we did with this project was we are collecting problem patterns in the Kubernetes cluster and send the problem patterns to the AI provider and ask them for a solution for this. So just to give you a short idea on how this could help you on your journey. So K8sGPT can be a service which runs in the Kubernetes cluster. Therefore, you could have an operator which is continuously looking for misconfigurations or things which are not working. And this twice, as it seems. And in some cases, if it finds some problems, it will write results to custom resource definitions and can send Slack messages if it finds something. At the moment, there are also things going on to say, yes, I found a problem and I have the second AI in it to find out where to find a solution for it and send it somewhere. But this is future thing. These are future things. Yes, the next thing which did not work. So to wrap this talk up, because I only have 1 minute left, what we learned today is still the learning curve is pretty steep, but compared to many other mechanisms, Kubernetes is not so complex as you might have thought. So just try to get, if you didn't get familiar with it until now, it's a good idea to start with it. And try to find out where the similarities between Kubernetes and the typical Linux world is, and you will find out it's not as different. The second thing is, for developers, platforms can make the learning curve less steep. So they want to ship their applications, in fact. They don't want, they might want to care about Kubernetes, but in fact, it's not their job at the beginning. Therefore, with platforms, it can be easier for them. For me, deployment is a fundamental aspect of the platform. So take this in consideration as early as possible. And last but not least, it's all about the people. So take them into consideration when building platforms, when creating new mechanisms, and so on. Yes, I also created an article for this. And yes, with this, it's all about the people, right? So thank you for your attention. And yes, I think we have some questions, right?
Yes, Thomas, we have one question. And thank you for the presentation. Sorry, and the question is quite simple. By the way, I would like to say thanks to Vladislav, who finally named, and we have question from a person, not from anonymous. Which approach is better, single architect or group of people sharing this role for the designing the platform, or could it work without such role? You as an architect can say to us.
I was a consultant 1 year ago, so I have to say it depends. So if you are pretty small, then it can work with a pretty small. If the company is pretty small, then everything can work with a pretty small group of people. If the company gets larger, and you need a centralized approach for all of this, you might have a platform engineering group which takes care about the architecture of the platform, which deals with some standardization. So, for instance, when we have infrastructure templates, when we have service templates, where are they and how are they structured and in which format? So then you need architects in place, but in the end, for me, it's working together. So at first, yes, you can create a framework for such platforms. So to say, yes, we have these repositories, put your modules there. But in the end, you should do this together with the developers, and in the end, developers should be able to contribute to this. Did this answer your question?
Yes, thank you. We have one more question. Any good on-prem or EU-based alternatives for K8sGPT? I think that it's coming from people who are familiar with GDPR, with all other things.
Yes, K8sGPT. Because in fact, normally in the beginning, K8sGPT doesn't send any data. So if you don't tell it to send data to the AI, then it won't do anything. The second thing we also have is that K8sGPT can use local AI as a provider. So you can run your models locally and can query K8sGPT on premises. And I think there is a company out there from a speaker which comes today, which is also here today, they implemented K8sGPT into their platform, and they are based in Europe, and therefore it's also working perfectly. But at the moment, K8sGPT, I think we have 9 or 10 integrations. We are anonymizing data as far as possible, and therefore it's an open source project, but we are trying to take care about the data as far as possible.
Okay, we have one more question. Did you get a real profit with K8sGPT compared to traditional monitoring alerting systems?
I think the profit gets. I think they fit together pretty good. So I know that many monitoring companies out there are using similar mechanisms. In the meanwhile, K8sGPT was one of the first projects which dealt with it, and at the moment it's for free, right? So at the moment you can install K8sGPT wherever you want. You can let it analyze your cluster, and at the beginning when we started with the project, the main idea was to make it your companion when troubleshooting things. So at the moment when I'm creating demos, the first thing I do is start the CLI, say K8sGPT analyze and so on, tell me what's wrong, and afterwards I know if it works or if it doesn't work. But in the end, I will need a monitoring system which takes care about my objectives, which monitors everything, alerts me, and so on. And this is far away from the purpose of K8sGPT at the moment.
Okay, thank you. It was really nice and amazing presentation from Thomas. And please applause to Mr. Thomas from Austria.
Thank you.
And we have a small gift for you.